Hello everyone. Now that we have a basic idea of what charge is, let's go ahead and look at how we charge objects. Because most things around us have an overall neutral charge. You don't notice charge on our kind of large scale environment, but we can make things have an overall positive charge or an overall negative charge, and there's a few ways to do that. So this video is all about charging, the different ways something can have an overall positive or negative charge. All right. First, we need to go over some background information quickly. Some of it's review, some of it's just quick info you should know to help us understand how this charging works. All right, first of all, again, when we're describing charges, we're just talking about how something might gain or lose charge, how it might become positively charged or negatively charged. Again, as was mentioned in the last video, the protons and neutrons are locked in the nucleus. It's those orbiting electrons that have the ability to move around. So we are always talking about the movement of electrons. That decides when things become both negatively and positively charged. You will never say, a correct answer will never be protons moved from one object to another. That doesn't happen. Okay. Now, because we're always talking about the movement of electrons, interestingly, when something does have a charge, it would have to be some multiple, some integer number of the charge of an electron. And what I mean is we already saw what the charge of an electron is. Negative, because electrons are negatively charged, 1.6 times 10 to the negative 19. Well, if this metal sphere, let's say it's a conductor, let's say I gave it a negative charge. Well, I could add one extra electron. Well, that would mean it has an extra charge of minus 1.6 times 10 to the negative 19. Maybe I give it even more negative charges. Okay, well, I can't add half of an electron. I can't split an electron in half. I can't add 3.4 electrons. So whether I'm making something negatively charged, I'm adding this amount of charge, and then another, and then another, and then another. It's some integer multiple. Same thing if it's positively charged, because remember, if something is positively charged, I'm removing electrons. Well, that must mean I'm either removing one of these, or two of these, or three of these. So usually you don't do the math on this, but you would have to always get some multiple, some amount that's in a quantity of integers of electrons. Okay, couple quick things. We'll assume in all these example problems and pretty much any question you'll come across that the objects we're dealing with are conductors unless otherwise stated. They're not going to trick you and have the answer be, haha, you weren't told it's a conductor. So we'll assume charges can move unless it says otherwise. Air, however, is an insulator. Electrons don't like moving through air. That would take a lot of energy. Okay, you might not like someone. You might want to repel away from someone. Maybe you would repel into another room, but you're probably not going to like jump out of a window and fly through the air to get away from someone. It's the same thing with electrons. Electrons might be attracted to protons. They might be repelled from other electrons, but they're not going to fly through the air in none of these problems. Again, that would require quite a lot of energy. And of course, for charging, this is our basic idea. If there are opposite charges, they want to attract together. If there are the same charges, they want to repel away. Okay, first example of charging, it's known as polarization. And polarization actually has something stay the overall charge that it had to begin with. It's electrons that are rearranging themselves based on the presence of a charged object. So here I have a neutral object. And remember, sometimes we'll show a neutral object just with no like pluses or minuses. It's implying that they're balanced. But I could have this. I could do plus, minus, minus, plus, plus, minus, plus, minus, plus, minus. Okay, again, there's an equal number of pluses and minuses, so it's neutral. I'm not implying there's only 4 electrons. Okay, I'm not trying to say there's only 4 protons. There are trillions of each in any object. But just the same number of these pluses and minuses imply that it's neutral. Let's say that I brought a negatively charged object. Negative, let's say it's just a metal rod that somehow got a negative charge. Now I'm bringing it close. So this is the same object. What's going to happen now that there's a negative charge? It's brought close. It's not touching. Well, the electrons that are in this object, are they going to be attracted or repelled? They're going to be repelled. Electrons don't like other electrons. So instead of them being nice and spread out, maybe now those electrons are now like this. On this right side, the electrons repelled away. They're not jumping through the air, they can't, but they are like, ooh, I don't want anything to do with this thing. I'm going to repel away, leaving over here the positive charges. The positive charges did not move. Remember, those protons are locked in place. These pluses here are not implying that protons moved to the left. They did not. They're there because electrons left. This electron right here went, oh man, see ya, I'm going over here, leaving behind those protons. Okay, this is a major idea. The electrons are always the things that move. When I have pluses drawn, that's never to imply that protons were added. It's to imply that electrons took off, they left. So electrons were repelled away. Now notice that the right side is negatively charged, the left side is positively charged, but the overall charge is still neutral. It still has an even number of pluses or minuses. This is polarization. It's when something becomes polarized. The negatives go on one side and the positives that are left behind are on the other side. Okay, that's polarization. Next example, conduction. This is what happens when you have two objects that actually make contact, and charges might move from one to the other to try and balance out. Remember, electrons don't like other electrons, so if they can, they will repel away from each other. Protons might not like other protons, but who cares? The protons are locked in place. So here's an example. I have a negatively charged object. Let me get to my red pen. Negatively charged object, and let's say this is a neutral object. I'm not going to draw the pluses and minuses here because it'll be easier if I just keep that as blank. So this is very negatively charged. I'm not saying there's no protons, there definitely are, but there's clearly more electrons. Now they're brought in contact with each other. So what do you think is going to happen to some of these electrons? Some of them are going to go to this sphere over here. They're going to repel away. Do you think all the electrons are going to move over? Well, no, because if that happens, now you have all the electrons on the other sphere. If you're in a room with 5 other people that you hate and then another door opens, you're not all going to go into the other room. That's not going to help you out. Instead, kind of the best scenario, let me erase these, is you want to try and balance out. Some of the electrons are going to stay, some of them are going to move. This is the best case scenario. If more than 3 moved over, well, then some of these would want to go back. This is what I mean by balancing out this attraction and repulsion. So now this object has become negatively charged because some of the electrons moved over. Okay, this one still looks like negatively charged, maybe not as negative as before. Okay, so one example. I have another example of conduction. Let's say now we have a positively charged object, and now I have a neutral object. Again, I'm going to bring them together. So now they're in contact. This side was positively charged, this side was neutral. What's going to happen? If you're thinking the protons are going to repel away, that is incorrect. The protons cannot move. But notice, this is positively charged. All we care about are the electrons. Let's look at the electrons over here. This is something they like. Electrons like positive charges. So when they make contact, some of the electrons are going to move over because they want to be with those positive charges. So before I had plus, 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 right like that. Sorry, can't draw. Some of those electrons are going to move over because they're like, hey, look at all these positive charges, me likey. All right, so now some of those negative charges move over. Here were those protons that were in this orange sphere originally. Are there as many electrons? No, some of them left. So what's happened to this orange sphere? It's now positively charged. Not because protons moved over, they did not, but some of the electrons moved over. And again, not all the electrons would move, but some of them certainly would. Okay? If all the electrons moved over, well, you know, there's trillions upon trillions of electrons in any given object. You might have too many, but some of them are definitely going to attract over. This object over here, it's going to become more neutral. Okay? maybe this one would even go over to go with this positive one, and then this one would be definitely positively charged. This one would be more neutral, but definitely this one is being more neutralized. This one is getting more of a positive charge, not because positive charge is moved, however. Okay, last example, or second to last example of charging. This is known as induction. Induction is pretty interesting. It's also the most complicated. It's when you have two touching materials. All right, so electrons could easily move between the two, and then based on some other charged object being brought by, that might make the charges move between the two. And then if they're separated, they might actually have some overall net charge, even though the charged object physically didn't touch them. Okay, that's tough by explaining it. Let's look at an example problem. I have two neutral objects. This one right here is neutral. This one right here is neutral. Same number of pluses and minuses. And then let's say I have this very positively charged object. Well, what's going to happen? Hopefully you're saying some of the electrons are going to move over here, because those electrons really like this positive thing. So let me draw those pluses again that I had. Plus, plus, plus. I had these three electrons that were over here. They're like, hey, I want to hang out with this thing over there. Boy, me likey. And some of these electrons probably moved over. They're like, ooh, I like that thing too. Probably not all of them did, because again, if all the electrons moved over, well, you know, those electrons don't like each other, but certainly some of the electrons are going to move over. So let's look, I'm just redrawing the pluses that I had from this first drawing. None of the positives repelled. Even though they might want to, the positive charges are locked in place. They're protons. So what charge does this have? Now this has a positive charge. What charge does this have? Now it's negative. Again, no charges jump through the air because air is an insulator. This is not touching. Now let's pretend I separated these two spheres. So I remove the bridge. These still have those electrons that are attracted, plus, 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 minus, minus. This sphere still has those missing electrons. So this still has that positive charge. This still has that negative charge. But now I've kind of removed the bridge. So even if, let's say I got rid of this, imagine then I remove the charged object. I took it away. Okay, I'm like, okay, well, that was fun. Now I'm going to move this far out of the way. Even if I did that, so this is no longer present. I should have went back to black. These things now have a charge. A charge was induced. Because a charged object came near, those charges rearranged themselves, and then because I separated them, they have that charge. Notice this thing never actually touched them. No charges actually left these original two spheres. They were induced to go from one object or the other. So now this has a negative charge, this has a positive charge. That's induction. There's only one more thing I want to say, and it's something known as grounding. This is the last little topic. If something is connected to the earth, we use the term grounded. Think of like the word the ground. And this is important because the ground is really big. The earth is gigantic, an innumerable amount of positives and negatives. If something is connected to the ground, the earth, just because of how massive it is, can very easily take away electrons. If I have something that's very positively charged, or I'm sorry, let's say it's very negatively charged, and I touch it to the ground, I literally take a wire and I touch it to the earth. Well, these electrons hate each other. The electrons could actually repel and go into the earth. Yeah, the earth might now have some extra electrons, but who cares? The earth is gigantic. It doesn't matter. If I have something that's very positively charged, and then I touch it with a wire, a conductor, to the ground, the earth, some of the electrons in the earth might move up. Be like, oh, hey, look at that positive thing. Yeah, the earth lost electrons, but who cares? The earth is giant. Grounding often neutralizes a material, okay, because those electrons could flee into the earth, or they could go from the earth into that charged object if they wanted. It doesn't actually have to be the earth. Any large object could ground something. A person could even ground it. A person is pretty big. Now, a person has a lot of pluses and minuses. Here I have a negatively charged object. This is called an electroscope. You don't really have to know that for the AP test, but we'll talk about it a little bit in class. If a person touched it, some of these electrons could go into the person because people are pretty big and those electrons could spread out. Electrons would rather be in something nice and big and spread out than being condensed in something where they have to be really close to each other. This diagram right here, this is my last little bit, this is a symbol for grounding. You might see this diagram and it just means something is connected to the Earth, so that Earth is available to give or take away electrons. Okay, those were the different ways of charging an object. Thanks for watching.